Hello guys, today I will be showing you a CUK converter circuit. It's also known as the boost box circuit, and depending on the duty cycle of the PWM in which I used a 555 timer, we can vary the output voltage. It's actually a DC to DC converter where it can go to buck operation or step down operation and boost operation or step up operation. Now, we made an improvised voltage controlled pulse width modulator. So depending on the input voltage of the CUK circuit, which is this part, we can actually vary the duty cycle of the pulse width modulator, and in turn varying the voltage of the output. Now, the assumption is that for a low voltage, it would go into boost operation where it would step up the voltage, and at a high voltage it would go into buck mode where it would step down the high voltage into a low voltage. So giving a practical demonstration is here. As you can see on the oscilloscope, at 6 volts, this is the waveform. Well, if I actually increase this to 12 volts, 12 volts, alright. The duty cycle of the waveform became different. Now it resulted into a step down operation from a 12 volt input to a 5 volt, roughly 5 volt output. Now varying back to 6 volts, it boosted up to 8.2 volts. Now there's a limitation in this circuit because of the regulating IC used for the voltage controller. Now this IC is actually used for the comparator circuit, rather for the comparator operation in the 555 timer control pin. So if you vary the regulator IC used, in which I used a 7805 IC, you can actually change the duty cycle that would be the maximum for the circuit. Now this setup is also applicable for a buck boost buck boost converter, where the CUK or the boost buck converter is derived from. Thank you for watching.